Welcome to the video series of machine learning. This is Dr. Jana, and in this video today we will be covering on this logistic regression. Let us have a look at what is this logistic regression and why it is so important. We have the supervised learning where we are having a number of regression like the linear, like the polynomial. The linear, again we have gone for the simple linear and multiple linear, and polynomial. These are things we already covered. And we have things like decision tree when you have to take a decision, and some random forest. Also, in addition to this above regression, we go for some classification problems. In the classifications we are having the k nearest neighbor, logistic regression, naive Bayes and support vector machines. And in this video we will be mainly focusing on this logistic regression. Okay, welcome to this logistic regression. Where we use this logistic regression, it is used for solving the classification problem what I told you. In our linear regressions we match or we fit into the straight line. In logistic regression, instead of fitting a regression line, we fit to an S-shaped logistic function S, which predicts two maximum value 0 or 1. That is the thing. So this curve, S curve, it looks like this. You can see it here. Here the x-axis is starting with 0 and maximum it is 1. So it is varying between 0 and 1. So this is the 0.5 which is the threshold value. So this is the things. So above this we will be matching to fitting to 1, and below this we will be fitting to 0, like this. Fine. So then in logistic regression, this y or the dependent variable, whatever you say, it varies between 0 and 1. So it can be between 0 and 1. So for this what we do, we divide the y by 1 minus y. So y divided by 1 minus y. You see, if y is equal to 0, 0 by something it is equal to 0, then value is equal to 0. If y is equal to 1, then something by 0 it becomes infinity. So it varies between 0 and infinity. Clear? Similarly, if you take the logarithm of that one, the logarithm of y divided by 1 minus y, and which is represented by this equation b0 plus b1x plus b2x2 plus b3x3, all the things are there. So it becomes, it varies between minus infinity to plus infinity, right? Then we have a number of other different type of logistic regression. On the basis of these categories, logistic regression can be classified into three types. One is the binomial logistic regression, second is the multinomial logistic regression, and third one is the ordinal. This binomial, whatever we say, so the dependent variable varies between 0 and 1, 0 or 1, pass or fail, like that. When you go for multinomial, in the multinomial you say we can go for minimum 3 or more categories like cat, dog or sheep, like that. Anything you can put it here, not cat, dog, sheep, you can cat, dog, horse, whatever things you put it there. Similarly, in the ordinal, in ordinal logistic regression, there can be 3 or more possible order types. Order types. So what is the order? What is the difference between the previous one and this one? That is cat, dog, sheep. They are not in order. But here order type means it can be low, medium, high. So this is the order. Low is the very less amount, medium is the in between, and high is the higher value. Right. So this is the things will be. Next we can move to our coding part. In the coding part, what we do, first of all we have to run this program. Okay. So for this running of this program, we need to go to our Jupyter notebook. So once you type the Jupyter notebook, you can see, and I click it here, the Jupyter notebook starts here, right? When the Jupyter notebook starts, you can see it here. Yeah, it is still starting. Yeah, it takes a little time. So once it starts, so it will be directing you towards one of the browser, and there we can use the Jupyter notebook. Okay, and in the Jupyter notebook we have to create a file, IPYNB, whatever the file is there. The file name we can go for this logistic regression, right? So I already done for you. So you can go for this logistic. Yeah, you can find it here. The logistic regression, this thing here, you can find it here. So when you are opening, you can clearly see. We will be using a data set the same as the user data. User data we have taken from this Kaggle, downloaded and saved it here. Now what we need to do, in the very first part of this implementation, we are implementing, as I told you, that using the Jupyter notebook. So first we go for the data pre-processing step. Here we import some libraries like the numpy, np, and matplotlib as plt and pandas as pd. Okay, then what we need to do, just you write all these things, then shift enter, it will run, it will show 1. Then we import the data set. The data set I have taken user underscore data dot csv. So this you can get it from this Kaggle. I have taken from it Kaggle and keep it there and upload here. For uploading the data, use the command pd dot read underscore csv. This is the method we use it, and the file name user underscore data dot csv, that you put a variable data underscore set. Right, now onwards we will be dealing with the data underscore set for reading this data. Right, now now we have to find what is the independent and dependent variables. So as you know, x is the independent and y the dependent variable. So x is equal to, then what I will be dealing, same data underscore set. So data underscore set dot ilog. So I want 2 to 3, all the things 2, 3 dot values, and for data set ilog y. So you define it here, you can drop and you put or whatever. This is the easiest way, using the Python you can do all the things, right? So you got this values x and y, you can print the value of x and y, you can understand. Then the third point, next point, what we do, we go for splitting of this data set into training and test data. Okay, so this, for the splitting we have to use a scikit-learn from sklearn.model underscore selection, import train, test and split. 3 things are required. So what are the 3 things will be in x train and x test, y train and y test, which is equal to this train test split of x y test size is equal to 0.25. Okay, so training is 75% of the data we are using for training, and 25% we are, then all the random size, random state is equal to 0. Okay, it is for the randomization. Then what we did for the scaling, again we do from sklearn pre-processing import standard scalar. So st underscore x, this is the standard scalar method we are using. Then I find what is x train and x test. So x train, x underscore train is equal to whatever things we put it the standard scalar st underscore x, this dot fit transform x train and this dot transform x test. So this is the one is the x underscore train, one is the x underscore test. So now we are able to go for the feature scaling. Finally we are going for this fitting the logistic regression. Previously what we are doing, we are fitting to a linear regression. No, then we, for these things again we need the sklearn from sklearn.linear underscore model, import logistic regression. I am importing logistic regression. Now this logistic regression, when the random state is equal to 0, this you put it as a classifier. Now for this logistic regressions I put this x train and y train, this I fit to the classifier. What is the classifier? The logistic regression what we are using for the random state is equal to 0, right? So then we use it this command classifier dot fit x train and y train. So it will show you all this says everything is okay. Then what we do, this classifier dot predict, when you take this x test, I have to calculate the prediction value of y. Okay, so this is calculated like this, y underscore prediction, which is equal to classifier dot predict x underscore test. Then you have to go for the confusion matrix. While you go for this confusion matrix, from sklearn.matrix import confusion underscore matrix and cm is equal to confusion underscore matrix. Up to this it is fine, right? Then what you do for the visualizations, so you run all the things, shift enter, it is running fine, there is no problem on that one. So you can also take all this, you can pause the video, you can write down this coding and you can also run it, right? Then while we are going for the visualization of the training set results, from we will be using the matplotlib. So from matplotlib dot colors import a listed color map, then x underscore set, y underscore set, which is equal to x train, y train, right? Then x1, x2, that is np, you know, this is the, I already used the np here, that is the numpy, you are using the numpy as np, right? So here I am writing, so np dot arrange start x set, this is the minimum, we put it here. Then you go for the plot contour map, we go for these things, then plot x limit, y limit, all things you do it here, and for ij then you go for the plot scattering of these things. Okay, then the title of this plot we are giving logistic regression, that is the training set. Then x label you are putting age, y label you are putting salary, and plot the legend, also plot the show. If you do it here, you can clearly see the 0 is shown here and 1 is shown here, and enter thing you can see it here. this is the age and this is the estimated salary. So this is done using this logic. Okay, then next what you do, from matplotlib columns, then we go for visualizing the test set. What is the previous one? It is the train. Okay, this is the training set of data, then we go for the test set of data. The same thing we follow it here and put it here, then plot the, so we can clearly see here. If you see still 1 or 2 after the testing and all things, you see that means what are the green, it should appear in the green, and what is the violet, it should appear in the blue. But still we are having 1 or 2. See here, this one violet color is still it is there, so 1 or 2 will be there. Those things we can delete. Okay, we can neglect those things. So this is the thing what we are using for this logistic regressions. I hope you got a clear idea about how this logistic regression works and what is the purpose of this logistic regressions. And I clearly told you that whenever we go for something like using the logic, it is yes or no or pass or fail or like that, in that case we are going for this logistic regression. Okay, thank you for watching this video. If you like this video, do share with your friends, and also don't forget to subscribe this channel also. And thank you once again for watching this video. Have a good day. Thank you.